You're riding in a bus moving slowly through heavy traffic at 2 meters per second, so the bus and everything on it's moving at 2 meters per second to the right. You hurry to the front of the bus at 4 meters per second relative to the bus. What is your speed relative to the street? Well, if you're moving 4 meters per second through the bus and the bus itself is moving 2 meters per second forward, we're just going to add those two things together. So someone standing on the street, on the curb, watching the bus go by, they see the bus go by at 2 meters per second, but they see you also moving an additional 4 meters per second to that. So we just add them together. 2 plus 4 is 6 meters per second. Rafi is pulling a toy wagon through a neighborhood at a speed of 0.75 meters per second. The caterpillar in the wagon is crawling towards the rear of the wagon at a rate of 2 centimeters per second. Two different units there, so we're going to have to convert the centimeters to meters. There's 100 centimeters in a meter, so we're going to move that decimal to the left twice. What is the caterpillar speed relative to the ground? We have opposing directions, so we're still going to add them, but the one going to the left is going to be negative. So 0.75 meters per second plus a negative, or otherwise known as minus 0.02, would give the caterpillar a speed relative to the ground of 0.73 meters per second. Again, you've got to convert. When you've got two different units, we want meters per second, so convert those centimeters per second to meters per second. An airplane takes 2 hours and 10 minutes to travel from Dallas, Texas to Orlando, Florida, a distance of 963 miles. If the plane maintains an airspeed of 480 miles per hour, did this plane encounter a headwind or a tailwind? How fast was the headwind, or how fast was the wind? 2 hours and 10 minutes, let's get this all into a single unit. Normally we use seconds, but since a plane's moving at miles per hour, let's just get everything into hours. So 2 hours and 10 minutes, 10 minutes out of 60, divide that and you get the fraction of 1.67. So we've got, the plane has 2.167 hours. So if they're traveling 963 miles and it took them 2.163 hours, their effective velocity was 444.39 miles per hour. Now they expected to have a speed of 480, but in actuality, they had a speed of 444.39. So if we look at that difference, we can decide, well, we can get a value for that. Now, a headwind blows against the face of the plane, so it slows it down. A tailwind blows against the back of the plane, pushing it forward and faster. And since we were slower, we're going to say it's a headwind. No, this is not something you have to memorize, but it's just like general knowledge to help answer questions. So since it was slower, it was a headwind. A traveler is walking on a moving walkway in the airport. If the passenger walks at a rate of 1 meter per second and the walkway moves at a rate of 2 meters per second, what is the velocity relative to a stationary traveler that is on stationary ground? So if someone's just standing there watching, if the person's not walking forward, they'll just move at 2 meters per second, but they're walking an additional 1 meter per second. We're going to add that. 2 plus 1 equals 3 meters per second. A boy is in the back of a pickup and decides to throw a tomato at a billboard. If he can throw at a speed of 70 miles per hour and the truck is driving at a speed of 60 miles per hour, then how fast will the tomato go if he? So initially he's going to throw it forward towards the billboard, and in this question and most questions there is no air resistance. So naturally the tomato is already moving at 60 miles per hour, and any speed that he throws forward is just going to add to that. Because if the truck wasn't moving at all and he threw it at 70, it'd be moving at 70. But the tomato was already moving at 60 and he threw it at 70. So we're going to add those together. 60 plus 70 is 130, in this case miles per hour. If the child instead waits until the truck passes the billboard and then he throws the tomato behind him, that's going to be an opposing direction than the truck. If the truck is moving forward at 60, he throws it backwards at 70. It's still 60 plus 70, but it's now plus a negative 70, because 70 is going the other direction. So just to avoid the negatives, and we're talking about speed, we'll just take the larger one first and subtract the smaller one. So 70 minus 60 would give us 10 miles per hour in the opposite direction. So it's 10 miles per hour back to the left. If we're talking about speed, then how fast, that's a speed question. Direction doesn't matter. If an unladen swallow can fly at a speed of 20 miles per hour against the wind and a speed of 45 miles per hour in the same direction with the wind helping it, then how fast can the bird fly when there is no wind? So we're just going to call x the swallow, y the wind. And when we add them together, x plus y, it was 45. And when it was x minus y, they're opposing each other, it was 25. Now we have two formulas with each one has two variables, so we can just add up the formulas. The y's cancel out. 2x equals 70, so x is 35 miles per hour.